Hi again. So today we're going to work on different types of derivatives using limits. So in our previous video, we talked about the difference quotient, and the difference quotient was represented by, let's write that, difference, darn it, is for us going to be our derivative, which is another way of saying slope. So we're trying to find this instantaneous change. How much is something changing at this one specific point? And that could be described as the slope of the tangent line at that one point. And as you look at the graph, every point on a curved surface, besides being a regular line, has a different slope. And we're going to use this formula here. The limit, as h approaches 0, of f of x plus h minus f of x all over h. So we mentioned before in our last video that this is really our y2 minus y1, and the bottom is really our x2 minus x1, which is our run. And this is our rise. It's really our rise over our run. Now, h represents the difference between our x values. So x2 minus x1 is our h. So it's how far these 2 points are away from each other. So to look at this practically, if I want to find the slope of this line here, from algebra 1, you need to use 2 points. And our problem is when I use 2 points, they're too far away from each other. If I pick up a point over here, darn it. If I pick a point over here, this line does not look like the tangent line we needed. So you pick a point that's closer. I pick a point that's slightly closer. This line here is better, but it's not accurate yet. And if I get even closer, this one looks pretty good, but still not close enough. And what we're saying is that h, the distance between my points, that's getting closer to 0. That's getting closer to 0. And as that shrinks, the y value gets closer to my original value, and we get a slope that is more representative at one point. So how does that look like when it comes to different graphs? Well, let's start off with a parabola. Our example is going to be y equals to x squared plus 5, let's say. Now, x squared plus 5, the parabola looks like a graph, 1, 2, 3, 4, 5. The graph goes up like this. Now, we're going to find the slope. We're going to find the derivative. And we're going to use limits to find it. So the main idea going back is I'm going to take 2 points and draw a line and say, hey, that is a slope, but it's not the slope I want. I want the slope at this one point. And this tangent line more looks like this. So as we take our 2 x values, x2 and x1, other way around, x1 and x2, we subtract them from each other. H is a difference between this x1 and x2. And what we're trying to do is we're trying to shrink this according to our formula up here. Make h so small that it's practically 0. These points are sitting next to each other or on top of each other. So all you do here is rewrite this as f of x, and we're going to copy this. Please take a look. This goes here, and this function here also goes here, except every time I see an x, now here's the special gimmick part. Every time I see an x, I'm going to write not x, x plus h. That's the only gimmick to this problem. Every time you write x, you write x plus h instead in the front. So the problem would be the limit as h approaches 0 of f of x plus h. We're going to say it's f of x is x squared plus 5. But in lieu of writing x there, normally we would write x here. We're going to write, it says plug in, and x plus h instead. So we're going to write x plus h. Minus, so you can write two parentheses if you want, minus the back function, which is just copy x squared plus 5. Just copy x squared plus 5, just the f of x. All over, just write the letter h. We are always going to write the letter h on the bottom. Now, here is the idea again. This is a y minus a y over an x minus an x. X minus x gives us the difference, how far those x's away from each other, whether h apart, rise over run. On top, our y minus our y, that's our old f, that's my old f here, versus my upgraded f, my x plus h version. So this is the last step, is we want to see what happens. So if you remember, let's go back to talk about limits. Whenever we're looking at limits, we just try to plug it in. And this is always going to fail on us for the difference quotient. But just to show you, if I plugged in, h is 0 here. H is 0. Aren't we left with just x squared plus 5 minus x squared plus 5? Because if h was 0, there is no difference between the front value and the back value. Now, if there's no difference, isn't that just 0? And wasn't h going to 0 anyway? So that's also 0. 0 over 0, we have a special word, indeterminate. We can't do that. We have to find another way. So because we end up with indeterminate, we know we have to find another way. So I'm going to go erase this and do this again. So instead of plugging h in, we said before when dealing with limits, let's see if we can simplify the problem first. So if you look here, I'm going to simplify this out. And then I'm going to multiply the negative out. And we're going to write this as one big line. X plus h squared, when I multiply that out, let's write the limit. It's going to be x squared plus 2xh plus h squared. That's what happens when you multiply x plus h squared out. Plus 5, because that's left over, right? We're minus x squared minus 5, all over h. Now, look here, spend a second here, and see, does anything on top, or do we have any like terms that would cancel out? X squared, 5. And this is what you should notice. Anything that's left over still has h's in them. And guess what? Those are going to divide out with the h on the bottom. Let's rewrite that so you guys can see it a little more clear. The limit as h goes to 0, we have 2xh plus h squared left over, all over h, because the x squared and the 5 both subtracted out. And this will always happen if you use the correct method. It will always simplify out. Now, we're going to go ahead and simplify the problem. I can divide h from both of these. Just to help you guys see this, I'm going to write one extra step. They both have an h in common, to make that a lot more obvious for you guys. Then the h's divide out. And we're left with the limit h approaches 0 of 2x plus h. Now, once we simplify a limit problem, we go ahead and plug in h again. Plug in our limit. If I plug in 0, we're left with 2x. And what is this? This is the derivative. This is the slope. The instantaneous change of f of x. So let's go back and take a look at this graph here that we had. I'm telling you that the slope of this graph is going to be 2x. What does that mean? It means that if you give me an x value, let's give us a table here. Here is x, here is y, and I'm gonna give you guys a new column today. We'll call it y prime. or this is the derivative of y. This is going to be our slope. So if x is 0, remember our graph is x squared plus 5. If x is 0, the y value is 5. But according to our y prime equation, our derivative here, we said that was 2x, right, from down here. That was our answer, 2x. Now here's the cool part. If I plug in the x value to my derivative, 2 times 0 is 0. At 0, 5, the slope is 0. That's what the slope is. It's flat. At x is 1. If I plug in 1 here, 1 squared is 1. 1 plus 5 is 6. Okay, great. The point is 1, 6. Perfect, 1, 6, yeah. But what's the tangent line? What's the slope of the tangent line? Well, if I plug in 1 here, the slope is 2. And we draw that by 1, 2 over 1. The slope is 2. The way I draw slopes, I put a dot, and then I count the number of steps, the rise and the run. On my left side, if I plug in -1, -1 squared is 1 plus 5 is 6 still, and that looks like that on the left. It looks about right. And if I plug in -1 to this, we end up with a -2. And look at the left side here. Is the slope positive or negative? It's negative, right? And the derivative, our slope equation, totally predicted that. It's going to be negative. As these questions get more complicated, imagine if you have a graph that looks something like this. Where the slope sometimes is negative, sometimes it's positive, and sometimes it's negative. And also, the slope is sometimes 0. Okay? Let's just say that again. Where the slope is negative, let's use a different color, negative going down. It's positive going up, and negative sometimes going down. We have the slope of 0, slope of 0. The y prime, our derivative equation, whatever it may be, will actually predict when it's going to be negative, positive, or negative, or back to 0. And that's what the cool thing about the derivative. It tells us what is the instantaneous rate of change. How is this graph changing? Are we losing money sometimes? Are we gaining money sometimes? Are we losing? When do we change? And we change at the zeros. You have to stop before you can change. Okay. So doing parabolas, let's go back and take a review. Whenever you're doing parabolas, you always end up squaring it, breaking it up. You'll always end up with like terms to cancel out. And then you can then simplify afterwards. Okay, let's do a different type of problem. We're going to do one that looks like there's really a couple of different types of problems, styles of problems that we'll see. And we've actually already gone through all the solving types. So let's do another one. Let's do example, y is equal to the square root of 5x plus 3. Okay, this is a square root problem. Now, if we set this up like we did before, this one is, we did radicals before. So the limit as h approaches 0, and we're going to write the f of x plus h version minus the f of x version. The new versus the old, okay? The new versus the old, all over h. So let's go ahead and plug in the value. This would be the square root of 5 parentheses plus 3. That's my new version minus my old version. Square root of 5x plus 3. The new version is the x plus h version. So after I remember to write x plus h whenever I have an x. This is being replaced. It's almost like your iPhone 10 being replaced with the iPhone 11. So for these types of problems, we could, again, practice by just plugging in h as 0. And if I plug in h as 0 here, aren't we left with just the variable x? And our problem is we end up with a square root of 5x plus 3 minus the square root of 5x plus 3 all over h, which is 0. And doesn't this and this subtract out to become 0 also? We end up with 0 over 0 once again, which doesn't work for us. So we try our other method. So let's go take a look what this other method is. How can I get rid of this radical on top? How can I get rid of this radical on top? And if you remember, we multiply by the conjugate, square root plus square root over the square root plus square root. So this method that we used to solve before, we've done it before. So to get rid of radicals, we're going to multiply by the conjugate. Now the conjugate here, we had a negative, that means we change it to a positive. Everything else must stay the same. All the interior plus and minuses all stay the same. So on the front, we write, sorry, oops, let me write limit. Limit h goes to 0. In the front, we write 5, open parentheses, x plus h plus 3. In the back, we write 5x plus 3. On the bottom, 5x plus h plus 3. In the back, 5x plus 3. So if we have square roots, we can write it in the difference quotient by plugging in our x plus h in the front and our regular problem in the back. We end up with 0 over 0 if I plug in h right away, so we have to hold off on that. We have to rewrite the problem instead using our conjugate. Our conjugate, instead of a minus, we use a plus. Now, up here, I'm going to write you guys a very simple illustration of what happens when you multiply something by the conjugate. X plus square root of 3. That's my easy version. So we're going to multiply that by square root of x minus square root of 3. Okay, this will save us a lot of time if you get the idea. So multiply front times the front. Since they're both square roots, the square root goes away. Square root of x times square root of x is just x. In the middle, square root of x times 3 is going to be a negative square root of 3x. But something kind of cool, if you look here, our next move, our FOIL, that will give us a positive version of that. This will always happen when you multiply by the conjugate. The middle terms always cancel out. That's why we use a conjugate. We don't want square roots. Use a conjugate, the middle terms cancel out because they have the square root. At the very end, we're going to say it's going to be minus 3. Okay, we simplify this. X minus 3. Here is the fast-paced version of doing it. If we are multiplying the conjugate, take the front out of the square root minus take the back out of the square root. That's it. That's how fast this is. If I say, let's try this again, square root of 5x plus square root of 2 times the conjugate, square root of 5x minus square root of 2, what do you think the answer is going to be right away? Square root of 5x times square root of 5x is just 5x. Square root of 2 times square root of 2 is just 2. Put the minus in between. And that's what we're going to do here. Let's go back to our problem. The limit as h goes to 0, the conjugate on top, the square root times the square root gives us just the 5, open parentheses, x plus h plus 3. In the back, square times the square root, let's give us a minus parentheses 5x plus 3. The cool thing is that that's all the work you need. Knowing this trick, that's all the work you need. When I multiply by the conjugate, it actually makes life a lot easier. On the bottom, go ahead and write, but you have to make sure to copy everything. We have not gotten rid of anything. Oops. X plus h, parentheses, plus 3, plus, write in the correct sign, 5x plus 3. Now on top, we're going to simplify it, get rid of some values. Let's rewrite it as 5x plus 5h plus 3 minus 5x plus 3. Oh, not plus 3, I'm sorry. Distribute the negative, minus 3. We simplify this here. We simplified this here. So this is now, just before we waste any more time, you notice like before, we're always going to have stuff to cancel out. We're always going to have stuff to cancel out. We have a 5x, 5x, 3 and 3. Those are all going to cancel out. And we're left with rewriting this limit as h approaches 0 of 5h over h square root of 5x plus h plus 3 plus square root of 5x plus 3. The goal again is to divide that h. If we can see that h here. Remember how we got 0 over 0? That's my 0 over 0 right here. That's my 0 over 0. If we get rid of that 0 over 0, limit h approaches 0 of 5 over the square root of 5x plus h plus 3 plus square root of 5x plus 3. Our next step, our last step here, is plugging h to 0. Plugging h to 0. And we're left with 5 over square root of 5x plus 3 plus the square root of 5x plus 3. Here is something I want you to notice. These are exactly the same. So when you add two square roots, you end up with 2 square roots because they're exactly the same. And that is our slope for the whole graph. So for whenever you have a square root, you will always write the conjugate version. And this always cleans up nicely on top. Okay, let's do one more example and something that again we've covered before when it comes to simplifying these types of limits, and that's using fractions. So let's do y is equal to 1 over x minus 2. 1 over x minus 2. Remember this graph has a vertical asymptote at positive 2 and a horizontal asymptote at 0. These graphs seem like they're kind of crazy. And the derivatives might be a little messy too, but they're really not that messy. Again, the 3 types that we're covering all have their own method of solving, and it's stuff that we've done before. So let's go and set up the derivative. The limit as h approaches 0 of 1 over, remember this is the f of x plus h. This is the new version in front minus the old version in back. X plus h minus 2 minus 1 over x minus 2 all over h. Now go ahead and take a look at the setup for me. And you notice the front equation and the back equation, the front equation and the back equation here, they look very similar. The only difference is the x plus h version here. So the gimmick to solve for this one, we can go ahead and try plugging in 0 right now, and we'll realize it's going to be 0 over 0. But our gimmick here is multiplying by what? How did I get rid of those fractions? We multiply by the common denominator. So for this problem, we need the common denominator. So the common denominator is going to be a little messy. It's going to be the front fraction as well as the back fraction. I'll do this to the top. See, this was the front fraction, and this was the back fraction. So we have to do that to both of them. We write it on top and bottom. Now, if you remember what we do, we multiply this, okay, to the front and the back, the front and the back. Okay, the front and the back. This to the front and the back. Now, one good thing is that since they have that denominator, the fractions will somewhat cancel out. So if I multiply this to the front, doesn't the x plus h minus 2 and x plus h minus 2, don't these divide out? Which makes the problem a little easier. And we're going to end up with just x minus 2. Let me write that for you in a large way over here. If I multiply x plus h minus 2 by 2 over x plus h minus 2. Okay, this is the front fraction. Doesn't this fraction divide out? And we're left with x minus 2. Minus in the back, x plus h minus 2 over h, x plus h minus 2, x minus 2. Limit. Okay. Now we're hoping stuff is going to simplify and cancel out. On the top here, I see a bunch of parentheses. Let's get rid of them. X minus 2 minus x minus h plus 2. That happens to the top. H, x plus h minus 2, and then x minus 2, just copying the bottom. Now, if you look at the top, a couple things are going to nicely cancel out. X, x, 2, and 2. We're only left with only one letter left. Negative h over h, x plus h minus 2, x minus 2. Take a look here, what divides out? Top and bottom. Rewriting this, we have the limit h goes to 0 of negative 1 over x plus h minus 2 and x minus 2. Once we get rid of our offending 0 here, 0 is 0, we can now plug in our h is 0, and plug that in, we end up with negative 1 over h is now 0, right? That's gone. X minus 2, x minus 2. Negative 1 over x minus 2 squared. And that is our derivative for this fraction. I'm going to go ahead and give you guys a practice sheet. Really, it's only going to be about 4 questions, and you guys can take a look at that.